Okay, it is Tuesday, and that's the starting bell. Yay! All right, Tuesday the 9th, and it's partial fractions. Now, partial fractions is not calculus; it's algebra. It's a way of making a fractional integrand easier to integrate by making it a bunch of fractions added up. Okay, what? Well, this would be the third week of a 4-week sheet, so 2 weeks ago. Yeah, that's the back of the sheet. The sheet you got. The last sheet you got. Okay. All right, so let's say I wanted to integrate stuff like, let's see. How would you do this? The integral of x minus 2 cubed over x squared minus 4. So we're dealing with like quotient rule stuff again. Remember, there's no unique one quotient rule. There's ln, there's arctan, there's all kinds of crazy stuff. There's trig sub, right? Well, here's some new quotient rule stuff today. Any ideas how you would tackle this? You can do this without partial fractions because the degree of the numerator is greater than the degree of the denominator. Ethan? Well, the numerator is already factored, so difference. Yeah. Okay, but couldn't we reduce it a little bit first? How do you factor the denominator? Okay, I'm going to write it out. X minus 2 times x plus 2. All right, so some x minus 2 cancels, and we end up with this. Now, this is the same integrand except at what canceled, x equals 2, right? So this is not valid at x equals 2, but elsewhere we could use this as for a definite integral or something. And we get that. And now let's do what Ethan said. Expand the numerator. That's it. Whoops, we said squared, didn't we? All right, so square it, and you get x squared what? Minus 4x plus 4, okay. And that's over x plus 2. The point here is that you can handle this antiderivative because the degree of the numerator is greater than the degree of the denominator. Why? How? What do you do? Any ideas? Ethan knows everything. Well, what do you think? Any ideas? This is not partial fractions. Partial fractions is when the degree of the denominator is greater than the numerator. So we'll get to that in 1 sec. But no, yes, maybe. I'm just trying to show you that you know how to deal with this without any new stuff. Well, what's a fraction really? Shorthand for dividing, right? Denominator into numerator. So divide it out. You know how to divide long division, don't you? X plus 2 into x squared minus 4x plus 4. Dividing, right? So x and x squared goes x. X times x is x squared. X times 2 is 2x. They're both positive, but we're subtracting, so add the opposite, change the signs. And you get negative 6x, bring down to 4 because we're dividing by a binomial, so we need a binomial. And x into negative 6x goes negative 6. So negative 6 times x is negative 6x, and negative 6 times 2 is negative 12. But remember, we're adding the opposite because dividing is fast subtracting. And you get a remainder of 16. So that means it's over. Right, exactly. So we can rewrite this integrand as x minus 6 plus 16 over x plus 2, all of which you know how to integrate. All right. So that becomes the integral of x, what was it, minus 6? Yeah, x minus 6 plus the remainder over the divisor, which was x plus 2. Yeah. And now you know how to integrate all of that, right? It's almost like 3 separate integrals. So this one, x squared over 2 minus 6x plus, well, don't forget the 16 in front, ln absolute x plus 2, and you're done. Right? Because if you think of it as a u sub, this is u and this is du, so it's a straight u sub. It's already 1 over u du times 16. And that's it. That's all I wanted was an antiderivative. All right? But now, so you know how to deal with this if the numerator's degree, in this case was third degree, is bigger than the degree of the denominator, second degree. Or in this case, second degree over first degree. But what if it's reversed? Aha. We're going to do partial fractions, not by parts, partial fractions. By parts is for products, this is a quotient. All right, everyone's got this? All right, so this is what's new today. And again, it's not calculus, it's a little algebra to simplify quotients. Okay, so let's say I want to integrate this instead. The idea is, can I break this up as the sum of one or two as well? They can't do the sum of one. The sum of 2 or 3 or 4 fractions that are actually easier to integrate. So forget the integral and the calculus for a minute. Let's do a little algebra. First off, can you factor the denominator? Yeah, what are the factors? What multiplies to negative 3 adds to negative 2? X plus 1, x minus 3? Okay. Right? 1 and negative 3 multiplied to negative 3, 1 and negative 2 added to negative 2. All right, there's a result from linear algebra, which I'm not going to prove right now, that says if you have 2 linear factors, you can break this up as 2 fractions with those denominators. And you can preserve the degrees. In other words, let's see. This was, wait a minute. The idea is that the denominator is a higher degree than the numerator, right? Well, what degree is this? 1. So what degree do I want up here if it's less than 1? 1 less. 0, that's a constant, just some number. Technically times x to the 0, okay? All right. And likewise, you can get a number here too. In other words, if you knew what these two numbers were, and you added up these fractions by getting common denominators, you could get this. Question is, what do those numbers have to be so this adds up to this? Again, this is just algebra now. Well, go ahead, get a common denominator. What do you multiply top and bottom by? X minus 3. What do you multiply top and bottom by here? X plus 1. And what's going to happen is the denominators are already the same, right? Aren't they? Okay, all I want to do is make the numerators the same. Otherwise, I don't have an equation. So, how do you get A and B? Why? It could be, but why? How do you know for sure? There's a unique solution. That's another issue here. It's unique. Well, all right. What if we distribute stuff? Now look what we got. We got ax plus bx has got to be 5x, because like terms combine, right? Ax plus bx has got to be 5x. Let's write that. A plus b better be 5. Isn't that the point? What else should I write? Same idea. Negative 3a plus b is negative 3. Okay. Do you know how to solve two equations to two unknowns? This is almost like I said, I have a line, x plus y equals 5, and negative 3x plus y is negative 3 is another line. Where do they intersect? You could subtract, right. We could do eliminations. Since we have the exact same number of b's, what if I subtract the bottom from the top? The b's will cancel. I can solve for a. And let's see, what do we get? A plus b is 5, and then the bottom becomes 3a minus b is 3. Add, and you get what? 4a is 8, so a is what? 2. And if you plug in a is 2, what does b have to be? 3. So b is 3. So that's what we're going to do. We're going to integrate this instead with 2 and 3. Okay? Any questions how we did that? So let's write down a result. I think I need another page. Can I move ahead? All righty. So the result is this, that this original problem can now be rewritten as a, which was 2 over x plus 1, plus b, which was 3, which became 3 over x minus 3, dx. I could make it one big fat integral or two separate integrals, whatever, same thing.